Cooling philosophy. Whenever any gas under high pressure experiences a sudden reduction in pressure, it results in a sudden reduction in temperature. The gas used is called a refrigerant. Some of the common refrigerants used in air conditioners are R22, R32, R410A, R134A. The high pressure is produced by a compressor. The function of the compressor is also to maintain a steady flow of the refrigerant. The high pressure is achieved by squeezing the refrigerant in closed container, and then releasing it when it has achieved the desired pressure. Various methods are deployed in squeezing the refrigerant, and accordingly the compressor derives its name. Types of compressors are 1. Reciprocating, 2. Rotary, 3. Scroll, 4. Screw, 5. Centrifugal. When the pressure of the refrigerant is increased, the temperature also increases. This is not desirable. So, the refrigerant is cooled. This is done in a condenser. The refrigerant can be cooled by the atmospheric air or water. When air is used, the condenser is called an air-cooled condenser. When water is used, the condenser is called a water-cooled condenser. Types of condensers. Air-cooled condensers. 1. The most commonly used air-cooled condenser in air conditioners is the fin type. 2. Water-cooled condensers. The most commonly used water-cooled condenser in air conditioners is the shell and tube type. On cooling, the refrigerant changes its state. It becomes a warm liquid but at high pressure. Now, the pressure of this warm high pressure is suddenly reduced by an expansion device. There are many types of expansion devices. The most commonly used are A. Capillary, B. Thermostatic expansion valve with external equalizer, C. Electronic expansion valve. Finally, this low-pressure liquid enters a large volume called the evaporator. Here the pressure is very low, created by the suction force of the compressor. The liquid refrigerant begins to boil. On boiling, the liquid refrigerant vaporizes. This is change of state. No change of state can happen without adding or extracting heat. The heat required for vaporizing of the liquid refrigerant comes from the evaporator body. The evaporator body picks up the heat from its surroundings. Here the surroundings of the evaporator is air. So, the air gets cooled. This cooled air is now circulated in the area required to be conditioned. This is the animation of the basic vapor compression refrigeration cycle. Energy efficiency. What is energy efficiency? In window and split air conditioners, energy efficiency is denoted by star ratings. It is denoted by EER, or SEER, or ISEER. Energy efficiency ratio, EER, equals cooling capacity in watts, divided by power consumed in watts. Power consumption varies from season to season. So, the unit is SEER. SEER equals seasonal energy efficiency ratio. But, seasons vary from country to country. So, in India the unit is ISEER. ISEER equals Indian seasonal energy efficiency ratio, This is star rating for split AC in SEER. Energy efficiency of chillers. Most chillers operate at part load, most of the time. So, energy efficiency is measured in IPLV, integrated part load value. IPLV is the average EER at different percentages of loading of the chiller. As per AHRI 551/591, SI, 2018 standard. A equals EER at 100% load for 1% of the total time. B equals EER at 75% load for 42% of the total time. C equals EER at 50% load for 45% of the total time. D equals EER at 25% load for 12% of the total time. The formula for IPLV for water-cooled chiller is IPLV equals 0.01A plus 0.43B plus 0.45C plus 0.12D. Units of pressure and energy. Units of mass, power, flow rate and velocity. MEP course. End of Chapter 1. Thank you.